All right, guys, in this video, we're going to review Pythagorean Theorem. Now, when we're reviewing Pythagorean Theorem, it is always good to start with the formula, right? The Pythagorean Theorem is a squared plus b squared is equal to c squared. Now, we can use that when we're trying to determine a side of a right triangle, or if a triangle is a right triangle. Those are the two different uses we have, okay? It all surrounds right triangles. If I have a right triangle, I can solve for a side if I have the other two. Or if I have three sides and I want to know is it acute, obtuse, or right, those are the two different things we're going to look at. Now, hopefully this is review. You remember some of this stuff. We're just going to review the main points of Pythagorean Theorem. So, in this first problem, they asked to solve for the missing side. They give us a right triangle, they've got two sides. So remember, when we're doing Pythagorean Theorem, the c squared is always the side opposite the 90 degrees. So let's take a look. This one right here is always going to be c squared. Now, some people make mistakes because they think, oh, it's got to be the slanty side, or it's always got to be the one in the top right. No, it's always the one opposite the 90. Now, sometimes it is the slanty one, sometimes it is the one that's in the top right, but sometimes it's not, okay? The only way that you know for sure you've got the hypotenuse, which is going to go in the c squared, the hypotenuse, is that it's opposite the 90 degrees. All right, so let's go ahead and plug this thing in. I've got 5 squared plus 12 squared is equal to c squared. All right, so I'm going to plug this stuff into my calculator. I'm going to plug in 5 squared plus 12 squared. If I'm using Desmos and I try and type this into Desmos, it will work, but I need to change the c to an x squared. In fact, let's just do that now. Let's, let me just back this up real quick. Oh, there we go. Okay, let's set it equal to x squared. That's probably a better way of expressing it. All right, so I'm going to plug 5 squared plus 12 squared in my calculator. And I end up with 169. And that's equal to x squared. All right, at this point, some people make a mistake. They go, oh, my answer is 169, but that doesn't make any sense. If these sides are 5 and 12, 169 is way too big to be the third side. So remember, I've got x squared. I need to take the square root of both sides. So I take the square root, and I get x is equal to 13. And that makes sense because the side opposite the 90 degrees, the hypotenuse, should be bigger than the other two sides. All right, let's try another one here. All right, I've got 9, I've got 14, I've got x. So the first thing we should start by saying, what is my hypotenuse? It is opposite the 90 degrees. That tells me that this is going to be my c value. Okay. Another mistake people like to make is they like to say, oh, the x always goes over here with c. No, it's always the hypotenuse. All right, let's go ahead and plug this in. 9 squared plus x squared is equal to 14 squared. All right, well, I can't just solve it the way I did before. I can't just add 9 squared and 14 squared. What I'm going to do is I'm going to subtract 9 squared from both sides. Okay? So I get x squared is equal to 14 squared minus 9 squared. See what happened there, okay? I subtracted 9 squared from both sides. So what actually ends up happening is if x is on the hypotenuse, I do the 2 squared and I add them together. If x is not on the hypotenuse, I do the 2 squared and I actually end up subtracting them. And obviously the bigger one minus the smaller one. So let's go ahead and do that. 14 squared minus 9 squared. Or you could plug this in from Desmos from once we set it up, if you put x in the right position. So I end up with x squared is equal to 115, and once again, we're not going to forget to take the square root of both sides. Second square root, I get x is equal to 10.723. Okay, I could take that out a while. Okay, 328. Okay, I'll stop there. All right. Generally, they're going to tell you how they want you to round. Usually, it's going to be to the nearest tenth. So remember, this is my 10th place, that's my 100th place, and I always check my 100th place. Do I round up my 10th place? Well, if it's 5, 6, 7, 8, or 9, I do. In this case, it's not, so I'm just going to leave it as 10.7. All right, so that's solving for a missing side. Now, we're going to do the other part, the second part, is it an acute, obtuse, or a right triangle? So let me move this guy out of the way. So once again, we're going to use the Pythagorean theorem, and all we're going to do is we're going to plug the two smallest in on the left side and the largest one on the right side. So let me show you. On this first one, 6.1 squared plus 7.4 squared is equal to 8.7 squared. All right, so 6.1 squared plus 7.4 squared, I get 60.86. And I got 8.7 squared on the other end, and I end up with 75.9 or 0.69. All right, so here's the question. If they are equal, it's right, but they're not equal. So here's how we figure out, is it acute or obtuse? And it looks actually like I'm missing a comma right there. There we go. That's actually better. All right, so notice this, okay? The left side is smaller than the right side, but I don't even want you to think about it in terms of like sides of the equation. What I want you to think is smaller or bigger. If the two smaller sides squared and added together are bigger than the biggest side squared and squared, then it's acute, okay? So we're to think about it like winning, okay? If the smaller sides win and they end up with a bigger number, then it's going to be acute because the sides are very close to being equal sides. If the big side wins, think about how that stretches open my angle, okay? If I've got a big third side, it really stretches open my angle, which goes bigger than 90 degrees, then it's obtuse. So this one, I notice the big side is biggest. This one is going to be obtuse. Okay, or an angle, there's an angle in the triangle that's greater than 90 degrees. I'm going to switch colors here. That's, actually, I don't know if we're going to be able to see yellow. Let's do green. Come on. I can do it this time. Here we go. All right, there we go. All right, same thing like before. We are going to go ahead and plug these in. I get 2.5 squared plus 3.5 squared. And we're going to ask the question, is it equal to 4.5 squared? Okay, so we'll plug it into our calculator real quick. 2.5 squared plus 3.5 squared. Okay, I get 18.5 on one side, and I do 4.5 squared on the other, and I get 20.25. All right, the larger one is bigger, so this is going to be obtuse again. Okay, notice that this one is bigger. All right, let me switch colors one more time. We'll go with blue. All right, let's try it one last time. Let's see what happens here. 7 squared plus 11.2 squared is equal to 13.2 squared. Okay, I'll plug it into my calculator quickly. 7 squared plus 11.2 squared. I get 174.44. And then let's do 13.2 squared. I get 174.24. Are those exactly the same number? They're not exactly the same, so this is not a right triangle. If they were exactly the same, it'd be right. Notice the smaller ones are bigger here, so this is going to be acute. Notice how these two add up to be a bigger side. All right, so I think you've got that covered. Last thing, sometimes you'll see this. Which of these is a Pythagorean triple? Let's see if we can make sure you can see all of that. Okay, so which of these is a Pythagorean triple? And all you're going to do is just like we did before. We're going to do 3 squared plus 4 squared. We're going to see, is it equal to 6 squared? We're going to do 7 squared plus 12 squared. We're going to say, is that equal to 14 squared? And we're going to do the last one. Notice, hang on, they rearranged the order. Remember, the smallest two, that's these two, need to go first. 10 squared plus 24 squared. Is that equal to 26 squared, okay? I'm going to check all of those in my calculator if I'm going to solve this problem. Whichever one comes out equal, basically you're just looking for a right triangle, whichever these come out equal ends up being the right triangle. In this case, this would end up being your right triangle. 10 squared plus 24 squared does equal 26 squared. So this wraps up our video on Pythagorean theorem.